Now, in this video, we're going to be talking about finding the angle of intersection between two planes. And so let's start with two planes. So we're going to have the planes, just for simplicity, x plus y plus z is equal to 0, and x plus 2y plus 3z is equal to 1. Now, the thing about the angle of intersection of planes is that we don't have to come up with vectors in the plane because we can get vectors that are perpendicular to the plane, and the angle that those perpendicular vectors are to each other will also represent the angle between the planes. So our vector for the first plane is 1, 1, 1. And the vector for the second plane is 1, 2, 3. So what we need to do is we need to come up with the angle of intersection between these two vectors. So again, these are the vectors that are perpendicular to the plane. They're the normal vector that defines the orientation of the plane. And so the angle between these vectors will give us the angle between the planes. So we use our cosine of the angle between the vectors is given by the dot product between the two vectors divided by the magnitude of the two vectors. So our dot product is going to be 1 plus 2 plus 3. And the magnitude of u is going to be the square root of 3. And the magnitude of v is going to be, let's see, 1 and 4 and 9. 1 and 9 is 10. It's going to give me 14. And so if I simplify this, I'm going to get 6 over the square root of 3 times 14 is, I believe, 42. And then to get the angle, we would just take the inverse cosine. Now, this is not going to be a nice angle, obviously. So I'm going to represent it in both radians and in degrees. So if I do inverse cosine of 6 divided by the square root of 42, I'm going to get 0.38759, blah, 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 radians, or in degree mode, and I'm just using my calculator for this, I get about 22.2 degrees. And again, the same properties apply as in other cases. So if the planes are parallel, they have the same or scaled normal vectors, but with different intercepts. It's pretty rare that you're going to get a example problem in a textbook where they're going to give you two vectors which are actually the same plane. You probably will be able to identify it just by inspection. So typically it's the vectors are scaled, but the constant is different. The constant is not perfectly scaled. So those would be parallel. If the planes are perpendicular, then the when we do our cosine formula, cosine, well, and even before we even get to that, the dot product will be 0, and therefore the cosine of theta will be 0, and therefore the vector, the angle between them will be 90 degrees. It'll be pi over 2. So when you get the dot product will be 0, you're already going to be able to tell that they're perpendicular. And if they're not scalars of each other, and if they're not perpendicular, then there's going to be some other angle between them. And then we can follow this procedure in order to actually find that angle. Now, keep in mind, this is not a signed angle. And it's just the smallest direction. So it's either going to be in the first quadrant or the second quadrant. So you're not going to get anything more than 180 degrees. We're not worrying about like which plane are we starting on or anything